Oh, um, good. Java 8 streams, ladies and gentlemen. We saw streams give us a lot of benefits in allowing us to express pipelines of computation that are potentially infinite in length in a very conceptually simple way, and we can use as much of them or as little as we need. Okay, they're lazy. In Scala, we only need to evaluate the elements when we need them. If we don't need beyond a certain point, it's never going to be evaluated. And we can use map, reduce, filter, etc. in a way that's straightforward here. Now, Java 8 has the same basic capabilities here. You can map, reduce, filter, request distinct values, flat map, limit, skip, etc. And you can, moreover, using streams, you can count up the number of elements of that stream. You certainly don't want to do that for an infinite stream. You can reduce it, you can do a for each over it, you can collect it, which will allow you to compute, for example, statistics. You could turn it into an array, etc. So within Scala, within Java 8 rather, we can take a collection and say, okay, render it as a stream, or even render it as a parallel stream. Parallel stream allowing for parallel evaluation, for example, of a map, and partial parallel evaluation of a reduce. You could say I want a stream of a certain value, and we can ask for an empty stream. As in Scala, you can ask for a range. A stream is a range from X to Y, for example, either including M and N or including N or not. And as in Scala, you can generate a stream using some supplier that generates successive values. You can iterate a stream, applying F, starting with some seed value, and then you apply F once to it, twice to it successively, just like is shown here. And there's some built-in streams to avoid boxing and unboxing that just return primitives. So an int stream, a double stream, and a long stream. Those are all defined as known types of streams. So streams in Java 8 are lazy. They are pipelined. Each stage doesn't compute all its results at once, but operates incrementally, just like we've seen in Scala. There's parallel and non-parallel ones that are very similar, and they can't be restarted. So here's an example of a Java 8 stream. Right? What is this stream compute? So this is a stream of, and this is one of these many places where Java 8 isn't quite as sweet as Scala. So this is a stream of int arrays. And these int arrays are all of the same sort. They're really just pairs of ints. Just pairs of ints. What does this stream do? Well, I mentioned the notion of stream iterate. Stream iterate basically takes a seed, an initial value, and then it takes a function which is then successively applied. So the first element is the seed, the next is f of the seed, f is this function, the next is f of the seed, the next is f of the seed, etc. So what does this do? It's the Fibonacci numbers, ladies and gentlemen. Yeah. The Fibonacci numbers are represented by the first element, I think, of each of the pairs within it, each of the int arrays. And so here we could, using that array, we could limit it to the first 20, and for each of them we could print it out. Right? Streams don't have to be a finite extent. This is a conceptually infinite stream. Here we're asking for the first 20 of them, right? We're asking for the first 20 of these elements. Here's an example in classic Java versus in stream notation. So here we have this thing called group. Group is a collection. And here we can go through each person in the collection. We can ask, are they in a certain state? And if so, increment a variable and return that variable. Here we're just using this variable to total these things up. Or we can convert group to a stream, filter it to just include those people who match this predicate, and then count the number who match, the number who result from this filter, right? So here, we're basically treating this group as a stream. We are reducing it to only include those who pass this criterion. We're counting up the number. We've used a lot of code like this in Scala. This is the same type of code in Java 8, okay? And there's a lot of collections in Java 8 that you can just say render it as a stream. It turns it into a stream, and then we can apply these successive operations in much the same way we've gotten used to in Scala, right? In this sort of pipelined way. Again, I don't have time to go into this, but it turns out that we can take a stream and we can do lots of useful things with it. We can group by certain things. We can concatenate the elements in it. We can sum or we can average the elements in it. As long as it's a double string, an in string, or a long stream, it knows how to average. Same thing with summing things up. We can reduce it in a way we've been used to doing in Scala by allowing it to be reduced according to an arbitrary a function as long as it matches a certain type of signature. And we can do statistical summaries with this stream very easily. So for example, here we could have a collection that is rendered as a stream, and then here we group it by one criteria, and for each of those groups we apply a count. So we get a count back, okay, of those who are of a certain ethnicity or of a certain age here. So this allows us to go through a collection, group it, and for each group apply this. How would you do this in Scala? What would you do? Do we have group by in Scala? Yeah, you bet we do. So we could do group by, and then what would we do to get sort of this count here? We'd first group by, and then we would do a map values. Map values, indeed. We would do a map values on it. So the group by would give us, for each of the things by which we're grouping, it's kind of a whole collection of the items in there. And then in map values, we would map each of those values. So it's a key value thing that you're getting out of group by. The key is the thing you're grouping by, the age in this case. The value in Scala would be the set of all elements that had that age, set of all people that have that age. And then you would do a map values where you take each of those collections associated with a given age and map it to the size, right? This is the way of doing it in Java 8. Different, powerful, significant. Here basically, take a look at this. Here we are grouping them by ethnicity and taking the average age within that grouping. Requires you to think a little bit differently, but you can use these collectors to kind of compute on these Java 8 streams after doing a grouping by. Okay, Java 8 streams, ladies and gentlemen. Many of the same benefits, many of the same ideas, many of the same operations that we're used to with Scala streams available to you day to day in Java 8. Okay, the latest version of Java, and one that's been out now for probably 2 years, something like that. So it means being able to replace code like that with code that's like this and can be expressed as a series of successive operations. Okay, so Java 8 streams are a big feature of Java 8 that allow for some very elegant patterns and enhance the programming, the functional programming style allowed by Java 8 functions.